In today's video, we're going to talk a little bit about molar mass and unit conversion. And you probably remember in the past we've done unit conversion. We've used these formulas when we wanted to convert from grams to moles, and then moles to grams, and or maybe we wanted to go clear to atoms, moles to grams to moles, and then moles to atoms, or we could convert back. These formulas should look fairly familiar to you because we've used them in the past. And maybe we could start with just a little review, just in case you don't remember how these work. If you had a problem where you were given 56 grams of nickel, and you wanted to know how many moles of nickel, you'd have a grams to moles problem, and you would grams to moles, you would use this formula right here. Okay, so you're given, you'd always start with your given 56 grams of nickel, and then next to that you have the 1 mole is equivalent to whatever the atomic mass of that element is. We're just doing a particular element here of nickel. So this ends up just being a simple division problem. The 56 divided by the 58.6934, the atomic mass of nickel, or whatever element you're trying to find. Simple division, and you come up with your answer. You've got your number of moles. Okay, and if you wanted to go clear from grams to atoms, so perhaps with a penny weighs 3 grams, you could convert from grams to moles using the molar mass of your element, in this case copper. So grams divided by the molar mass of copper, and that would give you your moles. And then you could use the next equation and go from moles to atoms, but by the use of Avogadro's number, and that's just a matter of simply multiplying, and you would have how many copper atoms you would have. Now, things get a little bit different if we're not talking about just single elements. If we're talking about molecules, we have to change things just a little bit. The equations are still kind of the same, but let's talk about what molar mass is. Molar mass is how much the molecule actually weighs. It's calculated exactly the same as what's called formula mass. The difference is that molar mass units are grams per mole, while formula mass units are atomic mass units. And that's not really that big a deal. Grams per mole, atomic mass units, that's not a big deal. We just need to figure out that molar mass is how much a whole molecule weighs, whereas instead of, let's give you an example here. Instead of just having the atomic mass of carbon, let's say we've got, that would just be atomic mass from the periodic table. Let's say you've got a molecule, let's say it's CO2. You'd find out how much the entire thing weighs. So you'd have the mass of 1 carbon plus the mass of 2 oxygens would give you the molar mass, the mass of the entire molecule. And our conversions pretty much go the same. I mean, we go from grams to moles. We're using molar mass this time instead of atomic mass. And if we wanted to go from moles to formula units or molecules, we could also call this is the same as molecules. We could use Avogadro's number to do that, just like we did with the other equations. Okay, so again, formula mass. The sum of the average atomic masses of all atoms represented in a molecule's formula. So formula mass, the mass of the molecule, so you can still measure it in grams or grams per mole, atomic mass units. So there's lots of different units we could use, and they're essentially the same. Okay, so those formulas we had before end up looking pretty close to the same thing. The difference is instead of having atomic mass, if we were doing individual elements, it's now molar mass because we're doing the entire molecule. And again here, instead of atomic mass, we have molar mass. We no longer have atoms to moles, we now have molecules to moles, but we're still doing the same thing, Avogadro's number. Same thing here, moles to molecules instead of moles to atoms, and the formula is still pretty much the same. Okay, so here we're going to have one that's all worked out. I've got it mostly covered up so you can follow along step by step. So the question, how many glucose molecules, and there's the formula for a glucose molecule, you may remember that from your biology days, how many of those are in 5.23 grams of glucose? So we're going from grams to molecules, but we have to convert to moles in between. So we're given 5.23 grams, and we have to convert that to moles, and we convert the moles to molecules. And you can do this in 2 steps, as I've shown you in the last slide, or we can do it all in 1 step. So you write down your given at first, and then you're going to convert that to moles. And remember, 1 mole divided by the atomic mass, if it were an individual element, or the molar mass, because we're doing molecules here, the molar mass of this molecule, how much it weighs, and then we've got it to moles. Now, to convert from moles to molecules, we're going to simply multiply by Avogadro's number, because there's Avogadro's number of things in each mole of whatever you happen to be talking about, in this case glucose. So let's find the molar mass, because we need that before we do anything. So how much does one of these weigh? Well, C6, we have 6 carbons. Here's the atomic mass of carbon times 6 plus the atomic mass of hydrogen times 12, because there are 12 of them, plus the atomic mass of oxygen times 6, because there are 6 of them. Now you do your multiplication and addition, and you should come up with about 180.1 grams for the molar mass of glucose. Now we can just plug that in. Let's plug in our numbers. Okay, so what we initially started with, this many grams of glucose divided by the molar mass of glucose, and here we have Avogadro's number over 1 mole of glucose, and this should get us to our answer. Okay, moving on. Here we have some practice ones, and rather than me working these out, you have the last one you can look back on to see how that works. You go ahead and give this a shot. You should be able to figure out how much 2 hydrogens weighs plus the mass of I shouldn't say weigh, the mass of 2 hydrogens plus the mass of sulfur atom plus the mass of 4 oxygens. You should come up with this right here, 98.079 grams, or grams per mole. And then if we plug that in to an equation here, if we're starting with 2.8 grams of sulfuric acid, we could convert that to molecules, how many molecules that is. And again, I'm going to let you work that out, because you should be able to do that now. And your answer should be right here, 1.719 times 10 to the 22nd molecules of sulfuric acid in 2.8 grams of the same. Okay, a couple more. Find the molar mass of calcium nitrate. Remember not to get confused here by these parentheses. This 2 means that there are 2 nitrates, 2 NO3s. So when you find the molar mass, that means there's going to be 2 nitrogens and 6 oxygens. So you multiply and add all those atomic masses together, you should get this right here for the molar mass. And if we had 8.5 grams of calcium nitrate, this compound right here, and we wanted to know how many molecules, you should be able to calculate that, and you will come up with 3.119 times 10 to the 22nd molecules of calcium nitrate. All right, last one. I didn't separate out the molar mass this time, because you should be getting pretty good at that by now. So let's do this one backwards. If we're given this many molecules of CH3O, how many grams are there? And by using the formulas that you've previously been given and calculating the molar mass, you should come up with 0.1185 grams of our compound. Okay, that's about it for this video. I hope that gives you a pretty good understanding of molar mass and how it can be used in unit conversions for molecules.